It's time to export the knowledge. So in today's video, we're going to be looking at the scalar product, otherwise known as the dot product. Let's draw a diagram to help us. So we have two vectors, vector A and vector B, and they form some sort of angle theta in between. So by definition, A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle in between. So with that, there's a few properties. Let's go case by case. So case 1, A and B are perpendicular. If that's the case, A dot B is going to equal 0. Why? There's something perpendicular, so the angle between them is going to be 90. What's cos of 90? Cos of 90 is 0. Case 2, A and B have the same direction. So let's say that's A, and let's say that there's B. If that's the case, the angle in between them is 0. Cos of 0 is 1. So what we'll get is A dot B is equal to the magnitude of A times the magnitude of B. Here's the third case. A and B have the opposite direction. So you can imagine A going this way and B going that way. In between them is going to be 180 degrees. And what's cos of 180? It's going to be negative 1. So A dot B is going to equal negative magnitude of A times magnitude of B. Alright, so what happens if we dot the unit vectors? So I dot I. Well, I and I have the same direction and same magnitude. But we'll write the formal definition. And the angle between them, because they're the same vector, the angle between them is going to be 0 because they're on top of each other. Cos 0 degrees. Cos 0 is just 1. And the magnitude of I is 1. So we can cross that out. That's 1 times 1 times 1, which means we're left with 1. Okay, what happens if we go I dot J? Well, I and J are perpendicular. But let's write out the formal definition. The magnitude of I times the magnitude of J times cos, and then 90 degrees this time. Cos of 90 is 0. Magnitude of I is 1. Magnitude of J is 1. Times it all together, we get 0. What if we had 2i minus 3j plus k dot 5i plus j minus 2k? And I wanted to work out what the angle is between them. It would make sense to just draw them, but this is 3D. So how are we meant to just draw it and then take some sort of angle measurement? This is where the dot product comes in. When we do a dot of something like this, we use the distributive law. So what that means is we'll get the first term, and we'll dot it with the first term there, and then the second term, and then the third term. And then we'll take the second term and we'll do the same process. And then we'll get the last term and we'll do it once more. Alright, sounds easy enough, let's do it. So I'm going to take the first term and dot it with the first term. So 2i dot 5i. Well, they're on top of each other, same direction. What was the case? If they're in the same direction, it's just the magnitudes times together. If it's only the magnitudes times together, because I is a unit vector, the magnitude is its coefficient. So we're going to have 2 times 5. Okay, so 2 times 5. Alright, now I need to grab this and dot it with the second term. So 2i dot j. Hold on, I dot j, the angle in between them is 90. If that's the case, they're going to be perpendicular. And that means we're going to get 0. So we'll add 0. Alright, now we'll get this and we'll dot it with the last term. So 2i dot minus 2k. I and k are perpendicular. So we're going to get 0 again. Alright, now we'll get to the second term here. So we'll dot it with the first one, perpendicular, we get nothing. Dot it with the second term, minus 3 times 1. We can do that. Same direction, just the magnitudes times together. We'll do it with the last term, perpendicular, we get nothing again. You can sort of see a pattern now. Alright, let's do the last term. Here we get nothing, they're perpendicular. We do it with there and there. Perpendicular again, we get nothing. Here they're on top of each other, we times the magnitudes. Minus 2 times 1. There was a lot of cancelling there. And if you noticed, only the k's dotted each other, only the j's dotted each other, and only the i's dotted each other. So you can simplify this by just timesing the coefficients of the i's, then the j's, and then the k's, and just sum it all together. Alright, so 2 times 5, that's 10. Minus 3, minus 2. That'll become 5. So now we have this number, and we can work out what cos of theta is now. We just find the magnitude of this and the magnitude of that, divide those two things. So all we have to do now is get the magnitude of this and the magnitude of that, and we'll get cos theta. So let's find the magnitude of this. So it's going to be 2 squared, 4, plus 3 squared. So that's 9. 4 plus 9, that's 13. Plus 1, root 14. That's the magnitude there. And here, so 25 plus 1, 26. Plus 4, root 30. 5 divided by root 14 times root 30. And whatever that is, that's going to be our cos theta. And then you can just use inverse cos to find whatever the angle theta is. So we said cos theta is going to equal 5 over root 14 root 30. So we'll do inverse cos. So theta is going to equal cos inverse of 5 divided by root 14 root 30. And that equals 75.88 degrees. You can put that into a calculator and it'll spit out an approximate answer like that. So that's it for this video. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.